Hi, I'm David, and this is what could very well be the first episode of this Central Talk. This episode is a pilot as part of my blockchain minor, which I am completing at the University of Applied Sciences. In today's episode, I would like to discuss about understanding decentralized ledgers. Then I will continue with describing in depth the proof of work consensus mechanism and how is it intrinsically different from the proof of stake mechanism. And afterwards, I will continue by continuing and developing more on what the Bitcoin 51% attack is and how it could happen, what the risks could be, but also like what are the possibilities for this to happen. I have decided to choose these particular topics because first of all, I think it's essential to understand what is a ledger, how it works, and with that, what are the different issues of centralized ledgers, and because of that, how decentralized ledgers could represent the solution in this case for a lot of in a lot of these cases. Afterwards, I will be debating and discussing the proof of work consensus mechanism and its inception, how it was created, what it represents, and why is it important to us, but also what are his potential drawbacks and his potential insecurities. And here I will discuss more about the Bitcoin 51% attack. And I think it's essential to assess these possibilities and to understand what it means and what it means for the network and what it could potentially mean for you as an everyday trader. And let's dig into it. First of all, let's discuss about what is a ledger. So you can imagine a ledger as a book or as potentially a book of transactions in which that records reality and mimics reality as closely as possible. And the purpose of a ledger in the real world is to record transactions so that for various reasons. So you can look at it as you can have the example as the transaction book that stores different objectives and different transactions into the prehistorical bank systems in which people used to use actual physical ledgers to record transactions among them, so that at the end they could keep accounting of the various of their business or the various reasons they would have used the ledger. And what's important and its connection to today's world is that ledgers are everywhere around us, and the depending on the level of extrapolation that you would want to integrate in your definition of a ledger, you can even see yourself as the ledger for the different types of molecules and different nutriments that you record into your body, and you can even consider your body to be a ledger. But further, we have to understand why are ledger important. And in historically and like in the beginning and inceptions of the idea of a ledger, it was born as a tool for recording financial transactions because people needed to keep account of the various transactions coming in and out into their situation, and because of that they were forced to come up with a means of keeping up these transactions up. Uh, One extremely important reason for which ledgers are everywhere around us is also because of compliance and regulation purposes. As in a lot of industry, or actually, usually every industry, and the processes in every industry needs to be compliant to various rules and regulations when it comes to like various transactions or procedures, and because of that each of these parts, each of these steps needs to be recorded, and that in compliance to various frameworks and models given by that central entity, government, or the entity that produced the ledger or produced the regulation needing the ledger. One other important part of all ledgers is that they bring a lot of transparency and accountability compared to the case of non-existence for a ledger. So basically, when we have a ledger, we can keep accounts of what happened, which transaction, and how each transaction was made, and how the way it came in or it came out. And because of that, we can easily keep accounts and have a lot more transparency rather than if we wouldn't have access to this kind of information. And this represented a big revolution in the idea of transparency and accountability. Another important point for ledgers is that they help in fraud prevention because they are able to by keeping the information and representing a centralized point that represents a centralized source of truth. It can always be referred to from any context or from any position, so that the decision can be made in regards to what is the truth in conflicts or in various other moments. And another point for the importance of ledgers is that they keep innovation, that they promote innovation, as in the sense that there's constant attempts of various players, of various entities, to basically fraud the ledger and to find ways of profiting from the system. And because of that, all the systems always needs to be updated, and there is this constant need of innovation to keep up with the level of innovation on that side. And because of this, lots of technologies, and since the inception of ledgers, lots of different methods and technologies have been devised constantly to raise the security levels of ledgers. But even though they do seem like just a fantastic opportunity and the fantastic update for people, of course ledgers do have their drawbacks. When it comes to centralized ledgers, one of the biggest issues actually with centralized ledgers is the central point of failure. What this means is that the entire power is held in the hands of one entity. It can be a bank when it comes to financial records of particular from of particular card, or it can be a government in that sense. But in any of these cases, or like depending on each, no matter what or how big the scale is, there can always be a central point of failure in which the network can be corrupted or just manipulated with harmful intentions. And because of that, because the power is just centralized and is just in the hands of one single entity, one single organization, one single person, uh, there's always the risk of a point of failure. The next point about the importance, what another point would be the idea that they have limited transparency. Obviously, as I was discussing earlier, ledgers definitely do bring in a lot more transparency compared to the case in which there is no ledger, but still, because of the idea of centralization, that there needs to be trust into the entity holding the ledger, because the entity holding the ledger has the power to basically modify the ledger, erase parts of the ledger, or reverse transactions, or basically manipulate it in any way, and then delete various transactions or tracks. And because of that, basically there's always the risk of that entity holding the ledger to manipulate it in various ways. And because of that, and because of the fact that if you're not that entity controlling it, you have no means of knowing what happens to the ledger or what's happening inside the ledger. Obviously, this situation leads to the limited that transparency. Another point is its vulnerability to cyber attacks, just because as it is clear, as it is centralized, and the entire part of data or various types of the data is centralized and is only held into one place, it is definitely a lot more accessible to various types of cyber attacks. Aside that, we can look at the lack of interoperability and issues when it comes to regulatory compliance when with various types of entities promoting or asking for regulatory for asking for regulatory measurements. And because of that, and in that sense, looking at these drawbacks, and we can definitely see the reason for which the idea of decentralized ledger was incepted, and why it became such a big part of today's technology. When it comes to decentralized ledgers, the situation changes abruptly as they promote significantly increased security. They promote greater transparency, improved efficiency. They add the idea, or they promote the idea of potential smart contracts. They allow the conception of decentralized finances. They are countered. They are together governed by the community, basically, as the community has the power of governing the network in itself. And because of that, decentralized ledgers definitely come as a big improvement. But we need to understand that based on the use case and based on the various needs of your project, or of the project or the task, we can understand why in some points centralized networks and centralized ledgers may make more sense for those particular contexts. But when it comes to decentralized ledgers, it's important to understand that that because of the way they are designed, and into their consensus mechanism, and the way the consensus mechanisms are built, they allow developments in numerous areas and industries and sectors. And followingly, let's discuss a little bit more about what decentralized ledgers are and how they work. As I was mentioning earlier, it's decentralized ledgers leads to increased security. This happens because, as opposing to like centralized ledgers, decentralized one have no central points, so that the ledger is basically coexisting into each node of the network, and it's basically self-replicating itself alongside and into each of the nodes of the network, and exists simultaneously everywhere without needing to be actually held in some type of servers, and to like be hosted into like an actual location. And because of that, it allows the idea of, and what it does with decentralized ledger is that it is operable and available to anyone willing to participate. Transactions are available and public for everyone in the network. As I was explaining earlier, decisions are made not obviously because there is no central entity there is no central entity that will take decisions. So the decisions are taken by the community in basically democratic ways. And in order to deep dive a little bit more into the diverse type of consensus mechanisms and why are they important, let's first discuss a little bit about proof of work. Proof of work is a consensus mechanism that relies on solving complex mathematical equations in order to verify transactions and add new blocks to the blockchain. What this does is that it is highly reliant on computing power, because the mathematical equations are obviously intentionally complicated. So because of that, and they require a lot of computing power in order to be solved. Because of that, and this the proof of work is basically the first consensus mechanism developed by Satoshi back in 2008, and when he published the paperwork of Bitcoin. However innovative and uh, magic would have seen in the beginning, soon enough after rewards started decreasing, as in the model described by Satoshi, there are 21 million bitcoins, and the rewards, and there is a certain amount of rewards that is given after every block, and the mechanism functions by halving up the amount of Bitcoin that is rewarded once in 4 years. Now we are at 6.25 Bitcoin per resource block. And because of that, because the decrease of while people were like after the decreases in the rewards, people started observing that, and like the with the intensification of competition, people realized that this model is not particularly sustainable, as it fosters a lot of computing power that needs to be that needs to be computed in order to solve these equations. And aside that, Bitcoin also fosters the risk of the 51% of the 51% attack. And let me dig a little bit more a little bit into it. The 51% attack basically represents the possibility of one person, entity, or even governments owning 51% of the hash power of, that's very important here, of the network. And in when it comes to Bitcoin, what's important to keep into account is the rule of the longest chain that is part of the functionality of blockchain of the Bitcoin blockchain. And what this represents is that basically the conflicts in Bitcoin is resolved by assessing the longest and the most complicated chain. So basically, wherever there appears to be a conflict, the chain with the most blocks is the one that is chosen and deemed as real. What could happen if there would be this miner or organization pool of miners owning 51% of the hash power? They would basically be able to solve hashing to solve the equations faster than anyone. And what this would lead to is basically the possibility of them to double spend. This could happen by them creating a private chain in which they would solve the blocks faster than any of the other miners, basically, beside any other miners besides them. And while this would happen, the transactions would be and the blocks would be normally resolved on the main chain by the rest of the miners, while this organization or person or entity would be building this private chain that would be built faster. And at some point he would publish that to the network, and because of the conflict resolution method with the longest chain implemented in the blockchain, the network would choose the fraudulent chain that was posted by this organization, thus allowing this organization to use that amount separately and have to transaction them before and basically virtually spending them without spending them, and leading to doubling that amount of Bitcoin. And because of all the situations of all these issues, the concept of proof of stake was introduced. Proof of stake was born from the need of an alternative that is less energy dependent. What this means is that because of all the fallbacks of Bitcoin, there's this need of a new type of consensus mechanism that would not require utilization of so much computing power, and because of this, the proof of stake mechanism was born. In the proof of stake, the stakers are basically locking up various amounts of the coin, and validators are chosen based on the amount of amount staked. So basically, the validator with the most amount of stake has the biggest chances of being redeemed as a validator and obtaining the reward into the blockchain. While there's also a the penalty system for various types of fraudulent securities. And in the proof of stake system, there is a lot more enhanced security, and it also allows the construction of various layer 2 and layer 3 applications. And I would like to take it for my presentation. I was David Sima.